now, this is a pretty short video. We're only going to do 3 examples, and then you will do an on your own problem, but you won't get this solution to it until class on either Thursday or Friday. So we're going to be working from these notes. So get those out. This should be just the next blank page that you have. And then again, the homework that we'll do for this will be in class. And then that's it. You won't have any homework for spring break. Woo! All right. So I'm going to connect to my screen. And let's do some screen mirroring. Jen Shones. Whoop, whoop. Okay. So last time we looked at composite figures, which were 2 figures that were put together to make a weird different shape. Today we're going to look at shaded regions, which means we took a shape that we know. It'll always be a shape that we know. And then we're going to cut something out of it. So this is used in construction when they're putting up drywall to try to work around outlets or HVAC, things like that. It could be used in engineering for trying to work out pieces to put together on a car or anything that you're making. This has a lot of uses in like the building type fields. So again, if you're interested in any type of engineering, you'll probably do problems like this. So what we're going to do is step 1, we're going to find the area of the whole thing, and we're going to call that the outside. And we're going to use that in our notation with the notes. Then we're going to find the area of the unshaded region, which we're going to call the inside, because the unshaded region is always inside the shaded region. Then we're going to subtract them, because if you take the whole thing minus the piece you cut out, you get what's left, which is the shaded region. Okay, so just like before, we are going to assume that any lines that look parallel are parallel, and we're going to round all our answers to the nearest 10th. Okay, so let's get started. We're going to start with number 2. And number 2 is a little triangle within a big triangle. So they give us all the measurements that we need. Sometimes we have to use deduction to try to figure out what's left to find maybe an unknown length. So the outside of this is the shaded part, the whole thing. So I'm going to find the area of the outside, and that's how I'm going to note it. So this is a great way to keep track of what you're doing so that I can follow your work when you turn in your homework. Okay, so the outside's a triangle. The formula for area of a triangle is 1/2 base times height. So I'm going to do, it's 1/2. The base, I'm going to call this right here, the 21. And so times 21, and then the height, I'm looking at the height kind of going this way, so I'm going to call it the 20. So 1/2 of 21 times 20. I'm actually going to cut the 20 in half and call it 10, and 10 times 21 gives me an area of 210. So the whole thing has an area of 210. Now I need to find the area of the little triangle, so we're going to call that area of the inside triangle. And you could use big and small, that's fine. I like to say outside, inside. So again, it's a triangle. So the area formula is 1/2 times the base, which is right here. They tell us the base is 7. That's this distance along here. And times the height, which they give us is 12. So I'm going to cut the 12 in half. I get a 6. 6 times 7 is 42. So to find the entire area, I'm going to take the whole thing minus the inside, so the outside minus the inside, and that gives me, when I'm done, I'm going to borrow here a little bit, make that a 0, make that an 8, make that a 1, make that a 10, and I get 168 inches squared. All right, so I found the area of the outside, I found the area of the inside, I subtracted them, and it's area, so it's still inches squared. Cool. Number 3, they're asking us to cut out 2 circles, and they only give us 1 measurement. So if you notice, this width right here, the 17, is also this width, which is what part of the circle? The diameter. Nice job. So what that means is that the diameter, this is also 17, and that means this is also 17. Which tells us that the right side of the rectangle is 34 yards long. So you can fill that in. Now we're going to have to use area of a circle, and it's we need the radius. So the radius is 1/2 of 17. So I'm just going to put down here that the radius is 8.5. Okay, now for these problems, I'm using 3.14. I'm not actually using the pi button. So if you're using the pi button on the homework, again, your answer might be off just by a little bit. Okay, so the area of the outside is, it's a rectangle, so 17 by 34. And again, I'm going to type those into the calculator for you just for speed of the video. That gives me 578. Okay. Now I'm going to find the area of the inside, and this time there's two circles. So I'm going to do something to my formula to show that there are two parts. So the area of the inside is 2 times pi r squared. So I'm going to use brackets because I'm going to use that in the next example, and I just want you to get used to it. So I'm going to do pi times the radius, which was 8.5 squared. Okay, so this right here is the area of one circle, right? And then I multiplied it by 2 because there are two circles in my problem. So I'm going to get rid of that. And let's see, I'm going to do 2 times, and I'm going to type in 8.5 squared and then times 3.14, and I get 226.9. And then when I multiply those two together, I get 453.8. So my outside was 578, my inside was 453.8. So my area is going to be the outside minus the inside, and that gives me a total of 124.2 square yards. Okay, there are a couple different ways to organize this problem. This was just the way that made sense in my mind. What's important is that you're able to show in your work and in the homework that you're going to submit that you found the area of one part of the figure, then you found the area of the other part of the figure, and then you subtracted. So all three of those should somehow be included in your homework. Otherwise, you'll get all messed up and then you'll get the wrong answer. And we don't want that. Okay, last example. See, I told you it'd be pretty short. So let's look at number 6. Okay, so number 6 is a hexagon with a circle inside. Again, we're working with a circle, so let's find the radius. So the radius here is 15. We just cut 30 in half. And then if you look at it, it's kind of hard to tell, but this, I'm just going to shade it so you can only see the top. What type of a figure is that? Nice, it's a trapezoid. So we've got a trapezoid on the top and a trapezoid on the bottom, and they're the same size. So we're going to use that times 2 formula again so that we can find the areas of the trapezoid. So the two trapezoids make up the outside, so I'm going to do that part first. So area of the outside is 2, and then I'm going to plug in my trapezoid formula. So just a reminder, trapezoid, area of a trapezoid is 1/2 times the height times base 1 plus base 2, because we're averaging them. So I get 23, and then it's tricky to see, but this 34 down here is this length right here. So that's actually the length of the trapezoid. So it's 23 plus 34. Okay, and then I'm going to close my bracket. So it's a little confusing. But inside the bracket is the trapezoid formula. Outside the bracket is the 2 because there's 2 of them. Okay, so let's get rid of those things. So let's do this. It's 2 parentheses. 1/2 of 15 is 7.5. And 23 plus 34 is 57. So using order of operations, I did what was in the parentheses, and then I did this multiplication. And now I'm still working inside the parentheses and brackets in this case. So I've got to multiply 7.5 times 57 to get that answer. So 7.5 times 57 tells me that each trapezoid has an area of 427.5 square miles. But I've got 2 of them, which is why there's the times 2 on the outside. So when I multiply those two together, my outside area is 855. Okay. Now I need to find the area of the circle that we're cutting out. So that's the area of the inside. And the area of the inside is pi times the radius squared. So it's pi times 15 squared. So if I type it into the calculator, 15 squared is 225. 225 times pi is approximately 706.5. Again, I'm using 3.14, not the pi button. And my final answer would be 855 minus 706.5. Running out of room here. And so my final area of the shaded region area is 148.5 miles squared. All right, so step 1, found the area of the outside, 2 trapezoids. Step 2, found the area of the circle. Step 3, I subtracted them. Okay, so the trickiest part's gonna be to figure out like what shapes you're working with and to organize the work.